Very good afternoon, ladies and gentlemen. I'm Sauradeep Sarkar, your host for today's webinar. It gives me immense pleasure welcoming you all to live webinar on the theme of Prepare Your Business for a Future of Cognitive. This webinar is hosted by Cyber Media Research in association with IBM. For the duration of presentation, all participants' line will be in listen-only mode. After the presentation, we will be having a question and answer session. And your feedback is very important for us. So kindly submit your feedback at the end of the webinar. I would like to now hand over the floor to Mr. Anil Chopra, Vice President, Research and Consulting from CMR, who will share his insights on integrating AI and cognitive into digital strategy. Thank you, and over to you, sir.
Thank you, Sauradeep, and very good afternoon to everybody. Thank you for sparing time to join us on this webinar on cognitive future. And I want to spend the next 15 minutes or so to really talk about, how do you really integrate AI and cognitive into a digital strategy. I think AI is something that we've all been hearing for a long time. In fact, right from my school days, I used to hear about artificial intelligence and how great it was. But it was just one of those, high funda things that will, only be visible in science fiction movies. But seems that, times are changing now, and we are actually seeing AI and the larger cognitive space. They are no longer just a technology that will take many, many years to come to become a reality. It has actually become a reality today, and it's being put to use by a lot of companies across different types of industries. So that's what I am really going to talk about largely as to from a perspective of how it's actually being used across different types of industries. And why that's important for you, because it gives a perspective on AI is already here, and you need to really start thinking about what to do about it. So first of all, I think I'm sure that you would have heard of Masayoshi Son, the CEO of SoftBank, who is basically recently acquired a mega chip designer ARM for $32 billion. Is a big time investor. And this is what he's saying, that AI is going to overtake human intelligence in the next 30 years. Now, by the time actually our kids grow up, they'll probably have a lot more AI-based devices to help them. And in fact, he further predicts that one computer chip will have an IQ of 10,000, within this period. So probably a pair of shoes will be more intelligent than human beings. So that is the kind of action that is happening, and how people are actually looking at investing in AI, and because they see a lot of potential in this area. Now, I wouldn't be surprised, because if you look at the entire ecosystem of devices that is around you, look at how they're actually growing and unraveling around us. All the social media, channels that are there, you're generating, you're using them. You use e-commerce. We use so many other devices at home which are connected. So whether it's even in the industry now, a lot of devices that we use for manufacturing are connected and are actually constantly sharing information, through IoT. So their entire ecosystem is actually growing, and it is actually generating lots and lots and lots of data. The question now comes is, what will you really do with this data? And obviously, all of it is not relevant for everybody. So we have to identify data that's relevant for our business. And which is where actually, it already started happening, and that's where algorithms actually came in, where, they started to make sense of data, which earlier, according to various surveys, suggests that, once you've accessed data, it is never accessed again. So that happens in 90% of the cases. Okay? So algorithms actually started gathering insights from those, all that data, and started, taking actionable insights from those. And we have seen many new products and services actually emerging, which are based on such sophisticated algorithms. And in fact, Harvard Business Review calls data scientists the sexiest job of the 21st century. So it is happening and hot because people want to make sense of data, and they need data scientists who can make sense of it using algorithms. So we are actually in the algorithm economy, and one very clear-cut example of that is, which is already prevalent, is in the e-commerce space. We see, many companies using algorithms in the e-commerce space very, in an advanced manner. E-commerce, for example, Amazon's recommendation algorithm will keep customers engaged and buying. Netflix has a dynamic algorithm that is actually built through crowdsourcing and, helps people and they keep watching. In fact, Myntra, the famous Indian e-commerce giant, actually designs 30% of its clothes with a bot. There are no people involved, and it contributes 5% of the sales. It might have been more now, I don't know. This figure is a little old, but the fact is that, they're actually using bots to design without any manpower based on the trends they see of, what kind of things are being purchased. Based on the purchase trends, they're actually going ahead and ordering and designing clothes and sending them out for ordering. So that's like a people-less department. So that's why a lot of indirect costs are saved, and it contributes to the sale. So this is actually already happening in the e-commerce space. Now, besides e-commerce, now a lot of other industries, are actually coming in, and beyond algorithms now, further developments have happened in the AI and the cognitive space, whether it's machine learning, whether it's computer vision, so many different areas, which are, robotics. So AI has actually branched off into so many different things that you can do today that, and it's further expanding. Now, I'll obviously not get into explaining what is computer vision or what is machine learning, but the idea over here is to look at examples of how various AI and cognitive approaches are being applied across different industries. And I think one of the most classic examples is to do with the chatbots and the robotic process automation. Many companies in India have started actually playing around with chatbots and started implementing them. And companies are actually embracing it to overhaul their support services, or they're using it to increase engagement or to drive more customers down the sales funnel. And these chatbots are artificially intelligent enough for the job to help you refine user experience. Just about every company, I think, you look at it, right from the auto rickshaw hailing app called Jugnu. I'm not sure whether, if you're not from Delhi NCR, you might not have heard of it, but the auto rickshaw hailing app called Jugnu is actually also playing around with chatbots, right up to, large companies and corporates like banks like ICICI, Yes Bank. We've seen many of them actually deploying chatbots. So that is it's obviously using AI. It takes time to learn, and over a period of time, they become intelligent enough to respond back to customer queries. Smart factories, another very key application of AI, and it can help gather data from sensors and then provide real-time updates to the management. In fact, according to some surveys, chief operating officers across the world are now increasingly demanding for this kind of digital transformation of their operations. So it's actually very much in demand. Autonomous vehicles is very interesting, and it's a very key area where AI plays a very key role. Cars guided by AI, they're using deep learning and sensor fusion to build complete 3D map of everything around the vehicle to empower the car to make better decisions than a human driver. And obviously here we see a human driver happily taking his own selfie while the car is driving on its own. It's actually happening already, and what they say is now Detroit, the city of Detroit, which was actually more known as a center of American automobile industry, has more software jobs today than automobile jobs. That is the kind of action that is actually taking place in autonomous vehicles. Now, in India, back home, I mean, since I did mention chatbots and RPA, we do have companies who are already advancing in robotic process automation. So here is a case of ICICI using RPA. In fact, they won an award from us as well recently to automate various tasks that were earlier hampering productivity. And as the business volumes were increasing, the number of human errors were actually going up. And as the transaction volumes were actually going up. So this actually automates many time-consuming tasks for the back-end teams, and they are actually bridging the gap between whatever systems and shortcomings that they had, and utilize the internal system functionalities to extend user groups, such as agents and brokers. Now, as you can see from the slide in front of you, for those of you who are able to see, there are many benefits that they've actually gained. And for the benefit of those who have logged in via only the phone, just I'll mention a few benefits that they gained by implementing robotic process automation. So this actually, the process of clearing up 100 transactions has been reduced from 4 hours to just 5 minutes. So that's a huge saving in productivity. Their fire and group health insurance policy digitization time was reduced from 4 hours to 1 hour per policy. And likewise, many other tasks for user management have been reduced from days to, many days to a few days, or from, many hours to just a few minutes. In fact, they've got 2% new agents and brokers on boarded as well. So huge, benefits of using robotic process automation by an Indian player. If I look at, use of AI in, it's not just in, the BFSI sector, but even across sports, fitness, and toys as well. And here you see on the right, there's this toy called the Cosmo, which is a little guy that has a mind of its own. It can recognize you, it can read your emotions, and it can interpret its own environment that is around us. It's a real-life robot that has a personality. It will play with you, it will learn, it will keep learning on its own and keep bringing out new tricks to keep the kids busy. So toys is a major area where AI is playing a key role. And likewise for sports and fitness, I think a lot of sports equipment nowadays is coming with AI built in, where they're actually having motion sensors that measure every aspect of your movement, irrespective of whatever sports you're playing. I mean, there are different types of equipment to depending upon the sports that you are playing, whether it's golf, whether it's tennis. There you can tie a band around your wrist for tennis. And it will measure all the relevant aspects and pass them on to an app that you can actually have on your mobile, which you can view and then figure out how you're actually playing. So it helps you improve your game. So likewise for fitness. So these three areas, AI is already being used by many companies. Now, same way we look at AI being used in content marketing and ad automation. And I think contextual advertising by Facebook and Google is a very clear example of how advertisements are being automated with the help of AI. They're able to recognize what ad to give where based on the context of the ad. In fact, we've seen companies which can actually recognize the ad even if it's not text-based. From videos and images also, they can make out what kind of image or video it is and accordingly target the ad to the relevant audience. It goes further where there are websites that can actually build themselves. There's something called the grid where you don't need to, find visuals or create a website. You just have to tell what you want, and based on what you tell, it'll create the website for you. So a lot of automation happening in this space, and in fact, there is Wordsmith which can actually generate news articles on its own based on the data that you provide. So that reduces the need for a journalist to create a report, fairly automated. So we are seeing a lot of automation in this. And likewise, if I look at it, there are so many different advanced places where AI and cognitive are playing a key role. Recently there was a successful example of robotic surgery, which was performed completely by robots successfully. Drones are another area example where e-commerce players like Amazon are actually experimenting with drone-based delivery of the various shipments. In China, there are robotic farms where there are robots that are controlling all the aspects of agriculture in the farms, and they are controlled centrally. So there are so many different applications where AI is already being used, is being put to use. And, it's quite fascinating to see how robots are actually gradually entering our lives and actually taking over many of the tasks and doing them quite successfully. So that obviously now brings me to the benefits and drawbacks, which currently are, if we look at in the AI space. One is that if you look at, say, bots, for example, they'll work 24 hours a day without complaining or getting tired. Obviously, they don't need a break, unlike humans. They respond faster to customers. They have this results in higher productivity, lesser errors. So they can, in fact, automatically detect security threats among vast amounts of internet traffic. And we have seen various examples of AI-based, security analysis. And there are some deployments by companies in India who are actually into this space as well, where they don't need, too many, as the number of threats increase, they don't need to have more people to analyze them. They can have, artificial intelligence to be able to analyze them and then start giving reports once they have done learning. But yes, there are drawbacks. There are some ethical issues as well related to the usage of AI. In autonomous cars, for instance, if a car is driving on its own and it has an accident, who is to be blamed? Because ultimately it's code that is actually operating the car. So there are those kind of issues that are there. And of course, the other issue of, the new generation being more used to talking to robots, rather than human beings. Because nowadays we are seeing interactive technologies coming into play. Look at Siri or Cortana. You can just tell them what you want and they'll go ahead and perform the task. Or recently now there are these robots that are coming in and they will be voice activated. You just tell them what you want and they will do it for you. The other caution that is there, of course, is that, for companies, if they don't deploy it properly, then, it can also lead to some problems. With incorrect responses, customers may not know whom to go to. I mean, if all they always face is a robot to talk to, sometimes they may prefer to talk to a person. And that could be a drawback for a company if they don't take action on it appropriately. Cost of creating AI machinery, of course, has to be really looked into because there will be multiple costs, at least I think initially while you are deploying something like that, because you will need initial manpower to do the learning and the training of the whatever implementation that you're having. And yes, the larger drawback that many people talk about, although this is still very much debatable, is the unemployment caused by the use of AI. But that's of course all debatable. Because every new opportunity that comes in technology will obviously have impact which will be negative, and there'll be a positive impact as well. So I think that's the kind of thing that is happening. It's not really science fiction anymore. As we can see, from the movies where we had robots which are actually the heroes of the movies like Terminator and Ravan and all those movies. You're actually having robots that are coming in. The robots on my screen on the right are actually the key highlights of the CES this year. They were the key highlights. And these are just a few of them. If you want to, if you're interested, go look up the robots at CES 2017. You'll come across a host of robots who can do all kinds of interesting and exciting things. They can recognize you, they can talk to you, they can dance, they can entertain, they can provide help to the elderly people at home. There are so many different use cases and applications of robots, and it's all right now happening around us. So I think in summary, all I want to say is that, there are so many different applications and technologies of AI, and you do need to keep track of them. You do need to understand which one is going to be relevant for your business. Only then you can put in a strategy of how you would like to leverage it, and of course with well-defined metrics. You don't want to get caught in a problem where it's being used but there are no metrics to really measure how it's going to really help your business. And then of course the bigger thing of being able to identifying and prioritize the data that is important for your organization and how it is actually being generated. Because of course it's all going to act on a whole lot of data that is coming in. Prepare an implementation roadmap and learn from some of the initial success stories from various companies. I think I mentioned some of them. There are some, you'll easily find many, success stories of AI, chatbots and all across the globe. And then start experimenting. I mean, I think that's the best thing to do nowadays on how, start experimenting with the various technologies. So with that, I come to the end of my presentation. And I'd like to now hand over the, controls to our next speaker, who's Sanjay Sinha, who's the India sales leader for Watson's platforms, and he's from IBM. And yes, he is going to tell you all about, how Watson can actually help you, and how cognitive is actually going to help you lead your digital transformation today. So thank you very much, and over to you, Sanjay.
Hey, thanks, Anil. Good afternoon, all of you, and I hope I have the presentation on. And so the topic that I'll be covering today, after Anil's introduction to the topic, is why cognitive computing needs to be leading your digital transformation today. And before I start off, admin, if you could just run the poll. If you could just take time to answer the questions. Okay, so I'll start off now, and
so Sauradeep, can we have the results now, please, of the poll?
The results are up.
Okay, right. So the results are that some people are there, some people who understand the technology, but a lot of people are not very sure about the technology, right? So good. So I'll just cover this. I hope that the introduction that I provide you today should help you to understand the technology better. Yeah. So just to give a context, this is a statement by Klaus Schwab. Klaus Schwab is the CEO of the World Economic Forum. He's the founder of the World Economic Forum, which happens annually at Davos. And he says that in the new world, it's not the big fish that eat the small fish. It's the faster fish that eats the slow fish. So if you look at the world today, disruptions all over us. There are companies like Airbnb, which have, or Facebook, or Alibaba, or Uber, right? All of these companies which actually own no assets by themselves, but have completely disrupted the models of the world economy. So disruption is all around us, and it is built on data, right? This data of a huge amount of data which is getting generated every day. Almost about 2.5 billion gigabytes of new data is being generated. Almost 80% of it is unstructured. And when I say unstructured, it means things like people talking on natural language text, or pictures, videos, audio files. So there is this huge amount of unstructured data which is getting generated through social media, and all of that is very, very valuable for industry. But it's still very, very dark data, because most of the computing till now was based on analyzing structured data, which is tables, numbers, rows. That's the kind of computing that existed today. In this new age, what we're finding is that expertise matters even more than before. And when we talk about expertise, what we find is that in this day and age, the best in an organization is probably performing at about 10x the level of that of the average. This is across almost all industries that we have surveyed so far. So if it is, say, the best oncologists in the world, they would be performing at about 10x the level of the average oncologist. If you look at even the best sales guy in an organization, obviously their matrix is almost about 7 to 8 times that of the average of your organization. Or be the call center rep, right? He, the amount of sales he's closing on phone, typically what we have found is about 7 to 8 times that of the average of the organization. So what does that mean? It means that there are some people who have figured out how to do things better than the rest of the organization. And what if we could figure out those attributes or those cognitive patterns by which people are making these decisions on how to communicate to customers or how do they decide on a particular medical case? If we could figure out the cognitive patterns or the way that people are thinking through and making decisions, we could make this, the organization perform at a much more optimal level than what it is performing right now. So at Watson, this entire project around cognitive computing is how we can augment the expertise of people using, the attributes that we are going to capture, through the interactions, right? So that is the partnership between people and computers that enhances scales and accelerates humans' expertise. So if we were to ask what is Watson, and this is also probably what we could define as cognitive computing, because Watson is a manifestation of cognitive computing. So Watson deals, on the right-hand side, as you can see the attributes, it deals with unstructured content, things like natural language, speech, vision, things which are very human-like, right? Natural language is a very human artifact, and it actually distinguishes us from the rest of the living creatures. But nobody's been able to actually capture the natural language capabilities, right, till now. The other patterns are around locating knowledge. How do we locate knowledge very quickly, and then serve it to the user? How do we identify patterns of behavior? Say, if a certain field engineer is on the job and he's doing it very well, how do I figure out that pattern, and how do I replicate that pattern for the rest of the field engineers? And of course, these are the attribute of machine learning. So over a period of time, we have figured out that if you can learn these patterns, we can apply them to the rest of the data that we are having. And of course, the flip side is that cognitive computing is still a very narrow domain science. So till now, machines don't have common sense. So they don't have morals, or they don't have compassion. So there's still these drawbacks, or there's still the limitations of the technology that we work with. So it's still very, very narrow focus. Like Anil said, you have this autonomous car. So the computer in the autonomous cars knows exactly how to drive an autonomous car, but it doesn't know to figure out the stock market prices or things like that. So it's a very narrow domain machine, and similarly, Watson is also a very narrow domain machine. It focuses on a certain domain. These are some of the kind of problems that we are trying to solve using Watson. And on the left-hand side is an image, if you can see, it's a yellow marked image, right? That's an image of a skin cancer, it's a melanoma that we are trying to track. And what Watson has got good at is that it's screened about thousands and millions of images around skin cancer, and it's able to figure out whether the lesion is cancerous or not. And it has got so good that it has got better than the best skin specialists in the world, right? So the amount of images that it has seen, it's learned from those images, and now it helps skin specialists to figure out whether the patient has skin cancer or not. On the right-hand side, you see the bus at the top. The bus is called OLI, and it's a 3D printed bus, solar power bus, and it is powered by Watson, the Watson Intelligence. So you can actually converse with the bus, and you can tell it where you want to go. The bus also detects your emotional state, and depending on whether you're happy or sad, it may play the appropriate kind of music, or give you appropriate kinds of emotional elevators. And on the bottom right, you see a person's face. This is the example of a company called Woodside Energy, which is an oil exploration company, a deep sea oil exploration company. And what Watson has done is that it has figured out almost about 38 years of knowledge of this company, and now it helps engineers in that company to figure out which oil bits that the engineers should go and drill the oil in so that they get their best output. What is backing all this technology? So there are these 50-odd underlying technologies that drive this platform called the Watson platform, right? So this platform ranges from things like language understanding to conversation to empathy. How do I empathize with the human being? So the human being might be angry at me at that point of time. If I'm a call center rep, or a call center bot, should I upsell or cross-sell? And that is going to be a pretty bad decision, because if I'm angry and the customer is angry, if I do a upsell or cross-sell to that customer, the customer is going to get really, really angry at me, right? So it's a wrong decision to make. So what if I could detect that tone in which the customer is talking and is chatting with the chatbot, and then if the customer is happy, only then do I do a upsell or cross-sell. And if the customer is really angry, we really apologize to the customer and help him through the problem accordingly. Similarly, there are APIs and around discovery, which helps natural language processing of data, and also domain language training. So, and I'll come to some of the use cases that we will talk about later. And of course, then we have APIs around speech recognition and visual recognition. So this is the Watson platform, and these are what we call API services. So you can start consuming them, or you can start playing around with them. They're available on a freemium model, so you can actually use these APIs without getting charged for a while, and then build it into your applications. So there are 3 cognitive patterns, and at this point of time, admin, could you run the second poll, please? So the question is, do you understand use cases around cognitive computing technology today? Could you flash the results, please, now? Hello?
So the results are already shared.
Okay, good. So, so I'll help you to understand the use cases around the technology now. So there are 3 cognitive patterns, and the 3 patterns are essentially conversation. The first pattern is called the conversation pattern, which is essentially around how do you scale human interaction. The second pattern is around cognitive discovery, which is in your content, which you have, which is this vast amount of enterprise content, your internal data that you have, and how do you find answers there? How do you unlock hidden answers there? And the third use case is around something what we call understanding signals in data. And I'll just move on to the next slide, and I'll explain each of these use cases. So the first one is cognitive conversation, so what we call scaling human engagement. So as as digital becomes more and more prominent, what we are finding is that people like to interact with digital rather than through the traditional technologies of voice, and therefore, in a typical digital journey, when the customer encounters a digital journey, most of these journeys are pre-designed by somebody at the corporate, right? And typically, if you go to a website, and I'll give you one example. So when I was trying to, for instance, try out, I was trying to get my home loan certificate last year. I went to the website of my bank, and I tried to figure out where the home loan certificate was. And it took me a while to figure out, although I'm pretty technologically savvy, it took me a while to figure out how I could get to my home loan certificate. And I pressed that link, and nothing happened. And I kept on doing that for a while, and I couldn't do that. So eventually, I picked up the phone, and I called up the call center. And after a wait, I finally got to the call center rep, and that person then sent me home loan certificate over mail, right? And so what I discovered was this entire process of getting the home loan certificate was actually broken, and it actually cost the bank some amount of money to send me this certificate when they could have done it for a very, very small cost, which is the digital technology. So you encounter these kind of broken digital journeys all the time because digital sites don't function the way that the customers want to. The digital sites function the way that the designers wanted them to, right? So what if you could change this, right? And so the cognitive conversation is around that use case, right? And the use case is that you have customers who are interacting with you through various channels, like social media channels, like Facebook, or through WhatsApp, or through mobile app, or your web browser. And they are interacting with you on a digital medium, right, these digital channels. And how do you interact back with them? And how do you fulfill their various needs through your systems of record at the back end, right? So here the use cases are things like being a customer assistant. So for instance, for a telecom customer, or can you provide customer service? Can you handle the inquiries, requests, or complaints, such as what is my account balance, or my data is slow, how do I increase the speed of my data, right? So you deal with these complex queries and delve at your back end, which are your CRM or billing systems or your HLR systems, and give back responses back to the customer. Similarly, what about conversational commerce? So can you increase the sale of your websites, through your websites, or your e-commerce sales, without increasing the number of salespeople, and having intelligent bots to do that for you? And the third one is around employee productivity, so things like internal IT help desks or HR help desks can be easily made into conversational engines using this technology. On the right-hand side, you see examples of what we're doing out here with companies like ABOF. ABOF is a fashion company which advises customers on fashion trends, and it uses a conversational engine from Watson to do that. Similarly, HCL has built a bot called the Lucy bot, which they use for handling IT help desk issues from their customers. The other examples are of a large airline which is building out a bot a conversational bot for its loyalty customers, and a large security companies which is helping customers to engage with customers to handle their issues regarding their stocks and trades. I have a small demo which I'll just show to you, and I'll just move to my screen. So this is a demo of 1-800-Flowers. I hope you can see my screen now. So As you can see, there is this bot called Gwen out there. It's a personal gift concierge, and I can speak to her in national language. So the bot says, my name is Gwen. I'm a virtual assistant here to help you. What are you looking for today? So I am looking for a gift for my wife. So it's her birthday, right? So then the concierge helps me through various gifts. I am interested in chocolates and flowers, and I submit that. So as you can see, this entire interface is very human-like. It's as if there's a customer service agent at the back end, and I can ask, and it keeps on leading me to, it's trying to upsell me, narrow down things, upselling stuff, and so on and so forth, right? So it's a sales, assistant at the other end. It'll help 1-800-FLOWERS sell more gifts to me and things like that. So I'll just move back into the presentation. So this is the first example, which was the customer service engagement bot, or the sales bot that I showed you. The second use case that we have is what we call the collaborative discovery pattern, right? So here the pattern is basically all of us are sitting on huge amounts of unstructured content, which is your company's knowledge at the back end, right? And there are things like customer manuals, knowledge hidden within salespeople, or knowledge within, within your traders, or knowledge within your, within your underwriters or claim agents, right, if you're an insurance company. So all of that knowledge is already there, hidden in your company, but it is unfortunately not accessible. So how do we make that knowledge accessible to people, right? How do we make the search, easy to do? And examples here are things like customer service. So a lot of your customers at your stores, if you're an auto company, for instance, they might have, and a customer is going for service, a car service, they essentially make a lot of complaints about what's happening with their cars. Most of these are written in the form of unstructured text, which is very difficult to actually go back analyze. Or things like product recalls, or if your field service engineer is going out in the field, how does he access all the information? The second example of this is your research insight. So, your enterprise sellers, for instance, can they get access to all the information relating to their accounts? Or can you get access to procurement data, right? Your procurement guys, do they know how to, what is happening in the world around certain commodities that they're trying to procure? Does your insurance underwriter get all the information needed to underwrite a claim, underwrite a policy, right? And so on and so forth. And then, of course, there are examples around contracts and legal and social listening. So on the right-hand side, you see examples here. There is this company called Ross Intelligence out in the US, which has actually built a Watson agent for understanding law and advising lawyers on or attorneys on certain specific legal issues. There is this company called H&R Block. It's one of the largest tax advising companies in the world, which has analyzed tax advice, and then it's built bots, Watson-based bots, which advise customers on what is the best strategy for for their particular incomes in that year. Manipal Hospitals uses Watson for treating cancer patients. So Watson goes and reads through about 15 million pages of text or research articles, and it is trained. This Watson for Oncology is actually trained by by the doctors at Memorial Sloan Kettering. So Manipal uses the knowledge of Memorial Sloan Kettering for giving advice to their patients. It's a very large paints company in India which uses this for tracking commodities across the world which they buy, right, for making paints. And there's a large telecom company in India which uses Watson for figuring out, where the call drops are happening and what kind of actions the engineers are supposed to take. So I'll just show you a small demo. This is an example of what I call the field service engineer. So this is the example of the field service engineer. This is the field service engineer's list of actions today. So he's got a lot of calls to do. He can open up the map and he can see where these calls are concentrated. Going back to the I'm sorry, it's got stuck here. Never mind. So I'll show you another one, which we call the claims processor. This is an example of how Watson accumulates this for claims processing in an insurance company. So there is this list of customers who have filed their complaints. I'll just go to Jennifer Lawrence and I'll see whether what we can do with her. So this is what Watson has done here is it's actually pulled out multiple reports from here, and what it is doing is that it is reading through these multiple reports. For example, if I were to look at the liability, this is a motor insurance claim use case that we're showing out here. So if I were to show the liability, what Watson will do is that it will look at it's looked at about 380 claims like this, analyzed. It's looked at all the required documents which are submitted. For example, the medical report which was submitted here, right? And this medical report will be, it's an unstructured report which is out here, which Watson is reading. And then it is computing the liability, right? And if you look at the settlement or things, right? So it's reading all of this with a high degree of confidence, right? So it's reading through, it's training through the similar cases, and it's coming up with what is the confidence level on the settlement, right? So basically, what is happening here is that the claims agent doesn't have to read through a lot of information. All of that is already being processed and decided by Watson, and all of the data is being given back. The final use case is around understanding signals in the data. So lots of very interesting use cases. Here what we are analyzing out here is things like speech and vision, right? And other things like data insight. So useful use cases around asset management, so product recalls. Some of the customers that we know are using Watson visual APIs, for instance, for looking at their tires, right? A lot of the tires come back as recalls. So they are looking at, and it is not possible to look at every single tire which is coming back, right? So they're using a Watson visual recognition engine to figure out whether the recall is actually needed or not. Similarly, there's a claims processing company or insurance company which is looking at claims by taking pictures of the claims which are coming in. So there are pictures of windshields that is analyzing and figuring out whether the claims is correct or not. Similarly, people are deploying it in their manufacturing processes. And there is this, the second use case is around customer intelligence. So how do we have call center agents being assisted by Watson listening to the customers talking in real time and advising the call center agent as to what actions the agent should take. Similarly, there are examples of email bots. So Watson reading through emails, the hundreds of thousands of emails which come in every month, and then responding back to them automatically. References here are people like ABOF, which is using a Watson API for matching the dress, right? So you have a dress which you like, and you put it to ABOF, and ABOF gives the similar kind of dresses that it has in its catalog. And so there's a company called Metro Infosys, which is actually using it for on India's toll roads for taking pictures of the cars and identifying which cars are going on the toll roads every day, right? So interesting use cases there. I'll just show you a nice video here, which is around the visual API, a very interesting use case that people are doing here. So this is a company called Aerialtronics, and what it is doing is that it is using Watson for looking at cell towers.
Every second of every day, billions of people depend on cell phone towers to stay connected. It's essential that towers are inspected regularly for such issues as rust, corrosion, and loose cables. But it's a tough job. Technicians have to climb to the top of a 200 to 300-foot tower. It can be dangerous, time-consuming, and expensive. Now there's a better way. Commercial drones from Aerialtronics can handle the inspection safely and conduct them more frequently. Cognitive visual recognition technology from IBM helps experts analyze drone images in more detail than is possible with the human eye alone. Using the Watson Internet of Things platform, the system identifies areas of concern and provides a confidence rating, so teams can determine if and when to make repairs. It constantly learns and becomes more precise over time. Aerialtronics and IBM Watson IoT can handle all types of challenging aerial surveillance, from managing crowd safety to assessing damage after an emergency to inspecting aircraft and terrain. Aerialtronics and IBM are working together to get a bird's-eye view of the world in a way that is efficient and cost-effective, keeping workers safe and everyone connected.
So lots of customers today use Watson. These are, we have across the world, and and several in India as well, right? So you've already seen some examples that I've shared, and there's many more that we are dealing with. So lots of customers have started out their cognitive journeys, and one point to be noted is it's not just large customers which are on the journey. There are very innovative small customers, small-sized customers who are on the journey as well. So it's an interesting time for all of us. And the Watson platform is pretty well known. It's pretty well respected. It's the leading platform. It's market making. So it's well appreciated there. As next steps, we would recommend you to visit this link. I'll share this link later with you. This is called the Watson Developer Cloud. You can actually type Watson Developer Cloud on Google and get there. And you can try out the Watson API. So most of the APIs are on a freemium model. That means that you can try them out and for free for a certain number of APIs, and you won't be charged, right? And the charging starts only at a certain level of API consumption. And then I urge you to contact IBM. And at IBM, what we promise to do with you is that we want to help you, handhold you to identify your use cases. We can help you build your business cases for cognitive, and we can guide you on your prototype, right? How do you build your prototypes? And also, like what a lot of customers are doing today, they're building out a center of cognitive competence in their enterprise. So we can be a partner for your cognitive journey. My email ID is given down there. And at the end, I want to run a small poll, as to what your interest in cognitive is after this presentation. So admin, if you could run that poll, please.
Sauradeep, if the poll is ended, can you show the results, please? Okay, the results are there. Sanjay, can you see the results?
Yes, I can. Yes. So there are several interested customers. So yes, we'll be willing to help with you. And Sonal, we can now open up for questions.
Okay, great. Well, thanks, Sanjay. Thanks for that insightful presentation, and I'm sure some of the examples you gave actually drive the message home about the potential of cognitive and AI. I think it helps understand things much better with an example. So, as you were presenting, there were some questions that were coming in via chat to us. So I'll just go ahead and start off with that. The first question, I think, was more directed at me, but I think, Sanjay, you'll also share your views. Basically, somebody said that this was referring to that Facebook AI project where they had stopped because the bots over there started learning on their own and created a language of their own and started chatting. So they had to shut down as a result of that. So, the person wants to know our opinion on that. Well, yeah, okay. Yes, so there is AI, as I said in my last slide, that AI will have certain drawbacks. There will be certain, problems and issues initially that might come in. But of course, we have to keep a watch of that. The larger picture is of all the benefits that it actually brings you. Not every AI project will have bots starting to talk to each other. I mean, there are, you have to look at the use cases and see what really fits, your requirement. So I don't know, Sanjay, you want to comment on this Facebook AI project that was shut down?
Yeah, sure. So we have a pretty strong view on AI for the enterprise, and a lot of the training that we actually give to Watson is a supervised training, because we believe that in the enterprise environments, it is important to train the bot rather than it learning on its own. There have been examples out where self-learning has happened and the bot has been uncontrollable, right? So we believe that the bot, because you are dealing with your customers, you need to train it for your enterprise, and there should be ample amount of supervision of the bot over a period of time.
Okay. So somebody wants to know are there any use cases in manufacturing for Watson?
Yes, several of them actually. So there is, I talked about a field service engineer. I was actually trying to show you the demo where it went off. But the field service engineer, in the manufacturing process itself, there is a process automation advisor. There are, like I said, in the visual recognition, we are seeing use cases around engineering drawings, around looking at as the manufacturing is taking place, using visual recognition to track the manufacturing. So yes, several of them, and in the industry 4.0 framework, cognitive is part of that framework. So there are several use cases there. Yes.
Okay, maybe we can share them with the audience after the webinar later on. We can share some links with them. So I think we'll be happy to do that. And somebody wants to know how much India is really ready for such initiatives in terms of cost and the data, because I believe obviously AI requires a lot of data.
So we get asked this question several times. AI is not like traditional computing where you require a lot of structured data, right? The project that we are after is dark data or unstructured data. So it doesn't need to be clean data, right? So that is what the AI, the cognitive computing, is trying to solve. So we are working with a lot of very innovative companies who start out with a certain amount of content that they have, and then they start building up, right? So they start small. A lot of the customers are starting small. It need not be a very huge investment that you're after. They start small, and then they build up their use cases, right? And that gives them the confidence to move ahead, right? So, for instance, if you're building a customer service bot or you're building a sales agent, you may not need to train it on all the 500 different intents or chat drivers that you're looking at. You can start with 2 or 3. You can observe that and then move ahead, right? So take use cases which are easier to do, and then as you gain experience, then keep on adding newer and newer intents or chat drivers. Similarly, if you're starting off with, say, you're a legal firm and you want to start off with certain aspects of the law, choose a narrow domain, attack that domain, and then move on to a broader set of legal data that you're looking at. So start small. There is no harm in starting small. This is all technology which is evolving, right? So there is no harm in working with this technology. And this technology, because it's so consumable, right? These are APIs. They're very, very cheap to consume. I'm sure that most customers will be able to work with us.
Okay, so you mentioned that you can start small. Which brings me to the next question. What sort of resources are typically required for this kind of a deployment at the minimum? At the minimum, what is the kind of resources?
So you actually, if you start looking at the APIs, you can start off with one person, right? I know several companies which are doing extraordinary projects with just 2 or 3 people, and they're not technical people. They're business people who are looking at the APIs, they're relevant APIs, for example, a visual recognition API. I know of a company which is doing exactly what ABOF was trying to is doing with just a couple of people, right? So because the API has become so consumable, they open up the API, they classify that API. In fact, there was another video which I wanted to show you where they built a bot in 4 minutes flat. Right, 4 minutes flat, right? It was so easy. So these are black box API with a very nice GUI, with very simple, instructions on how to go ahead. So you can start very small. You don't need too many people. You don't need data scientists to do this. You can start with business users. You can start with your current IT folks, and they'll be able to do it.
I see. And how would you compare IBM Watson with GE Predicts?
We are more of a general purpose API, right, which you then train it for certain domains. So what we do is that we have this API called Knowledge Studio, which helps us train it for various domains. So we are not tied up to a certain domain. So and I'm not really aware of the GE thing, but I'm just trying to just give you an example that you can use the Watson technology for any domain that you are in, right? Because we've got this training tool called the Watson Knowledge Studio, which enables you to train it for multiple industries.
I see. In fact, I'm getting quite a few questions from people about how is it relevant or the use cases for their industries. So the two more that I've got are for power generation and supply chain logistics industries. So are there any use cases available for these two?
For power generation, yes, we have some use cases around nuclear, and we have sorry for talking nuclear, but I've got use cases around nuclear, and then we've got around thermal as well. I can get back if somebody writes to me. I can get back to them. And on the supply chain side of it, we are working with a lot in procurement and for sourcing out vendors, for identifying commodities, right? So things like that we are working out. So, but we'll be happy to partner on newer use case that you're looking at.
I see. Okay, and what is cognitive testing and how is it useful? Somebody's asked this question.
Yeah, that's an outlier question. I won't be aware what cognitive testing is. Sorry.
Okay, fair enough. No problem. We can get back, to the audience later on. Not a problem. So we'll record this for our future reference.
Sure.
Now somebody wants to know about the Watson Developer Cloud. There is a Watson Developer Cloud, I believe, available.
Yes.
Okay, so somebody would like to know the charges for that and what kind of on-prem load can be shifted to this the Developer Cloud.
Right. So the Developer Cloud, what I can do right away, right? I can show to you right away, which is it's very easy to go to. So all you need to do is type the Watson Developer Cloud. I'll just shift to my screen. And I'll just show to you how it works, right? So you'd go to the Watson Developer Cloud. And on the Developer Cloud, you have these host of APIs that you can start off with, right? So, on this is things like the visual recognition. You have demos here. You can, you can figure out the pricing out here. So everything this is the landing page for Watson, right? And for instance, you can get demos. You can get access to APIs, customer studies, pricing, everything is out here. Now, just to give you an indication of the kind of pricing, right? So, for instance, for building a chatbot, if you wanted to build out a chatbot today, so there's something called the Watson Conversation Lite. Now, what Watson Conversation Lite allows you to do is that it gives you access to 10,000 APIs a month, free of cost, right? No charges, for about 25 odd intents. So if you have 10,000, as much as 10,000 APIs a month is free, right? You don't get charged for it. And if you go beyond that, then we charge you about 15 paise per API, right? So it's a very cheap service, right, that you can just start off with and start conversing with, for your various use cases. So it's actually, it's passes that we're talking about. That's the kind of API that you can start off with.
Okay.
It's like, unlike whatever you heard about IBM, right? It's not expensive. It's very easily consumable.
Yeah, I am sure that people will find that interesting and useful and to try out. Now, there is another question on this that, somebody is asking, don't you think that AI is actually slower and costlier as compared to human intervention? Because every time the system will take its own time to understand the customer before responding. So, it's like it takes time to respond, it takes time to learn. So, isn't it actually slower?
Not really. So initially, maybe. So if you take a human contact center agent, for instance, the contact center agent takes about 4 or 5 months to train up. So any decent call center will train up will give him or her about 2 months of training, and then he'll be put on the job supervision for about 3 months. So his total training time is about 5 months, and then this agent typically goes and attritions out after about 2-3 months. The guy goes off to some other company. So in case of Watson or a cognitive technology, the training time would be about 3 to 4 months when you build up all these use cases and train the agent. It is slightly lesser than what a human agent actually goes through. But then Watson doesn't retire, right? If the Watson doesn't run away to another job, Watson stays on the job, learns from every single interaction that it is having with customers. So the advantage of this technology is that the training stays on, right, within the enterprise. It doesn't leave the enterprise. And with every single interaction, Watson is the dumbest when you start training it first, right? But over a period of time, over 3 or 4 months, and then, after every single interaction that you're doing with your customer, Watson will learn, right? And then it becomes better and better over a period of time, right? So it becomes very, very smart at the end. So that's the advantage, right? And the cost advantage is obviously there so the way that we see the cost advantage happening is that it's like a hockey stick. Initially, it's a smaller curve, but then it becomes extremely cost-effective to go in for a virtual chat or a virtual bot vis-a-vis a human agent. But a human agent typically costs an interaction costs about $7 to $8 on 8 rupees on or 10 rupees for a cost of a human interaction. Typically, what we see on bots is about a rupee or rupee and a half, right? Those kind of costs. The other thing is that if that's just the call center agent, which is actually the cheapest commodity available. But if you look at more advanced use cases such as underwriting or claims and stuff like that, right? Underwriters are extremely expensive people. Claims people are extremely expensive. So obviously the economies pay out very well there.
Okay. So I think that finishes all the questions I've received over chat. So Sauradeep, is there anybody coming in via the phone call? Does anybody have a question?
Not yet. So ladies and gentlemen, should you wish to ask any audio question, you may press 01 on your telephone keypad.
Okay, we'll wait for a few seconds in case somebody has a question who is logged in from.
Okay, I think Mr. Surendra Gupta would like to ask a question on the chat. So,
on the chat or on the phone?
On the chat.
Okay, so we're waiting. Our chat line is open. We're waiting for the question. Okay, I think this question was already asked, Mr. Surendra Gupta, and we did say we'll get back to you. Sanjay, this is about the cognitive testing and how is it useful. So I think we will frame a response after this webinar is over and revert as soon as possible to Surendra. Great. Are there any other questions coming in on the phone line in the meantime, Sauradeep?
Yes, so we have one question from Mumbai location. I would request you to kindly state your name. Your line is unmuted. You may please go ahead.
Yeah, hi. My name is Rajesh. Can you hear me?
Yeah, we can hear you. Please go ahead.
Yeah. So my question is how do we make a chatbot for a webinar like this? If I were to make a chatbot for a webinar like this, is that a proper use case?
So you could. What you could do is that there is I'll give an example of a professor at Georgia Tech, right, and Professor Goyal, who actually what they did was that they used Watson so Professor Goyal used to teach a computer science course, and he was actually teaching artificial intelligence. So he built a Watson chatbot as a teaching assistant. It was a TA, and the chatbot was called Jill Watson. So nobody was aware that it was not a computer chatbot. So and then over a period of time, what they did was that they essentially trained Watson to respond back. Watson looked back at all the questions that students were asking. This was a MOOC course that they were running. So Watson was trained to understand what students were asking for and respond back. And typically these were admin issues that MOOC courses have. And at the end of the course, Jill Watson was rated as the best teaching assistant, over all human beings. So it learned its job very well. So I'm just drawing a parallel, right, when you asked me about this webinar, and I'm just thinking about Jill Watson, which was like a MOOC course assistant, which was helping out people on various things.
Okay, thanks for the articulation.
Thank you.
Okay, great. So while you were answering the question, I've got about 3 questions, and I think since we are already overshooting the time, we will end with these questions. So the one is about how can Watson help in machine learning to fetch some of the machine parameters and prepare trends or signatures?
So, so Watson works on unstructured data, and the 3 unstructured data sources I talked about were natural language text, vision, and speech. For machine data, we have another service called Watson IoT, and then we also deploy data science. So combining these 3 capabilities, we can address these problems, right? So we have data science, we have Watson IoT, and we have Watson to help you out there.
Okay. And is there any standard template for Watson on customer support?
There is, okay, so there are 2, you're right, so there's a customer Watson virtual agent, which is actually built out for multiple industries. So it's built out for telecom, it's built out for banking, insurance, energy and utilities, travel, and loyalty. Loyalty is going to come out now. So there are about 5 or 6 industries that we have already pre-built out Watson conversation templates. And then you have the Watson conversation engine. So there's a separate Watson conversation engine, which you can use for building out your own bot. You don't need to go to Watson Virtual Agent. So there are 2 kinds of Watson agents available on conversation on the chatbot side.
Okay. And the last question, does Watson support blockchain?
Yes, it does. It works with blockchain as well through the RESTful APIs.
I see. Okay. Well, great. Thanks a lot, Sanjay. I think that with that we come to the end of the webinar. And thanks a lot to all the participants. You've been very, very interactive, and thanks for sending us those questions. Whatever has not been answered, we'll try to get that answered to you as quickly as possible. And we will share some more use cases with you because I did notice that many questions were actually revolving around the use cases. So we'll try and be in touch with you after this webinar as well. So thank you very much to all the participants, and thank you, Sanjay. Just one last thing, that once you end the webinar, you're going to see a feedback form pop up on your screen. So please wait for that, because sometimes it takes some time to pop up. So just do wait for that, and then please submit the feedback form and give it back to us. We'll really appreciate it. Thank you very much, and have a great day ahead.
Thank you all, and thanks. Bye.
Thank you very much, Mr. Chopra. Thank you, Mr. Sinha. I would like to thank all the participants who joined us today. Hope you all have spent a useful time. With this, we conclude this session. So on behalf of IBM and CMR, I would like to thank all the participants for joining the session. We hope it has been a useful time. And thank you very much. You may all disconnect your lines now.